We now want to think about products where how much anyone's willing to pay for a product depends on how many other people are using it or even who else is using it, but for reasons that are different from what we've looked at before. Previously, we thought about products where seeing whether or not other people are using it provides information for you, and that affects how much you're willing to pay for the product. The classic example of this is actually a service that is thinking about a restaurant. If you look at a restaurant at a popular time of the day and you see no one in there, that conveys information that perhaps this is not really a good restaurant and perhaps affects your willingness to go. So that's one case in which whether other people are using something affects your willingness to pay for it. But there's another type of product where this occurs, one in which there's no information contained in what other people do. There's just a direct benefit from having others use the same product. Nice example of this is Facebook. If no one else is using Facebook and you're the only person there, Facebook's not very interesting. Facebook becomes more interesting the more people who use it. Now, actually, with Facebook, it also depends not just on more people using it, but actually who is using it, who among your friends. That would introduce a network structure. And for now, we're going to forget network structures. We're just going to think about products where what matters is the fraction of the population using the product. We'll bring network structures back in a little bit later. So think about some sort of technology or software where how much you're willing to pay for it depends on the fraction of people who use it. Perhaps because with the software, it's easier to get help if there's other people using the service as well. That's what we want to analyze, products which have network effects, where these are positive effects. But before we do that, we're going to start with products that actually don't have any network effects and figure out how the market works in this simpler case, and then we'll expand it to network effects. Because network effects actually get really quite complicated. So let's start without them for now and think about a good or a service where everybody wants to buy at most one unit of the good, but people differ on how much they value the good. So people are going to have different reservation prices for the good, where a reservation price for any person is simply the maximum amount that they're willing to pay for the product. And of course, those are going to differ across people. So we have to think about who the people are and what their reservation prices are. Let's give people the rather boring names of X, where X is some real number between 0 and 1. So we'll imagine the whole population between 0 and 1, and every X there represents a person. Person X has some reservation price, which we'll call R of X. What's that mean? If X has a reservation price R of X, what that means is that person X will buy the product as long as the price is no more than R of X. But if the price is above R of X, then it costs more than the person thinks it's worth, and they simply won't buy it. So every X is a person, R of X is their price. We need to figure out how those prices vary with people's names. And since we've made the names arbitrary, let's just line people up according to their reservation prices. Let's suppose that person named 0 has the highest reservation price, and reservation prices just decline as we move along from 0 out towards X equal to 1. So people with small names have high reservation prices, people with large names have low reservation prices. And in fact, let's make the person whose name is all the way out there at 1 someone who just doesn't want to buy the product at all. That is, let's assume that the reservation price R of 1, that is the price for a person with name 1, is simply 0. We can generalize away from that, but this will make our life easier. Okay. Now that we've got those reservation prices, let's think about how to graph them. Well, we've said that R of X is a decreasing function. Let's also suppose that it's continuous, right? So that at every price we have some X that matches it for any price at least below R of 0. So R of X is going to be some nice decreasing function all the way from 0 and R of 0 all the way down to 1 and R of 1, which we've assumed is simply 0. That person doesn't want the product at all. That's our little function of R of X. Now that we have that we have the reservation prices for everybody, let's think about how this market works. That is, suppose there's some price P in the market. Well, what's going to happen? Well, first, if the price P is above R of 0, then the good costs more than anyone is willing to pay for it and nobody buys it. It's not a very interesting case. Let's suppose instead that the good has a price somewhere below R of 0, but above 0. In our little graph, let's make that the price P, which is illustrated by that red line. Who's going to buy the product and who's not going to buy it? Well, go from P out to the curve for the reservation prices and look at the X you get there. That person X, where R of X is just equal to P, is the person with the biggest name X who is willing to buy the product. In fact, that person at R of X has a reservation price exactly P. That person's just barely willing to buy the product, but he will buy it. Everybody whose name is less than X buys it, of course, because their reservation prices are higher than R of X, which is equal to P. Everyone to the right of X does not buy the product because their reservation prices are less than P. Now we know how a market works when we have reservation prices for a good that people want to buy at most 1 unit of. Tell us the price P, we'll tell you who buys the product and who does not buy it. A nice thing about this way of thinking about the market is when we look at that person X whose reservation price is just P, that X also gives us the fraction of the population buying the product. And this is going to be really important later when we introduce network effects. At price P, the critical guy X is also the fraction of the population. So if X is the equilibrium here, it's X fraction of the population buying the product. There's one other thing to notice about this that's useful, is that at any price P, everyone who thinks the product is worth more than P, that is, has a reservation price above P, buys it. Everyone who thinks it's worth less than P does not buy it. As everybody's making a decision that they're happy with given the price of the product. There's nothing that they would want to change. We're actually in an equilibrium setting. Next, what we'll do is take this basic idea and then we'll add in the network effects, which is going to complicate it quite a bit, and figure out what the equilibrium looks like.